Just wanted to introduce our breakout session here. So today from Concertec, we have Jean-Nicolas Lanoux and we have Théo Drogo coming today to speak about FME's Flow's potential and architecture design for modern enterprises. Thank you very much.
Thanks, Nick. Just going to turn this. So, yeah, Nick said, I'm GIS Strategic Advisor at Concertec.
And I'm Theo, also GIS Strategic Advisor at Concertec. So just so you know, Concertec, we are a Canadian company. We do services all around North America. We do mainly GIS services, but also a lot of data integration, and we have FME in our product. So basically everything that's FME related, that's probably a service that we offer. So from training, assessment, developing project, that's our daily job, I'll say.
Great. So today the goal is for us to help you unlock the full potential of FME Flow by making the right architectural decision, whether you're deploying it as a new user of FME Flow for your first time or scaling it across your enterprise. So basically, as it is a 20-minute session, definitely we won't be able to cover everything, but we wanted to give you a little bit of insights about what we're going to talk about, the fundamental of defining an architecture and deciding which one is better between the three that are available, the express, the distributed, and the fault tolerant. We will have also a main focus on the different type of engines that are available into an FME Flow architecture, and other things in terms of decision points, key decision points for choosing over one architecture over the other. And we'll end that with real-life scenarios of implementation of FME Flow. And quickly, in terms of the out of scope, we're not covering the really defined stuff like FME Flow hosted or everything in regards to, I saw Nick going, containerization, Kubernetes, containers, and stuff like that. And everything also in regards to the licensing models, although we're going to talk just a little bit because it's part of choosing your architecture. And everything that you won't see in the next slide won't be covered. So let's start. So in terms of the architecture fundamentals, I wanted to draw a picture of what are the main components. So if we start, there is the FME Flow core. It's basically what drives the entire FME Flow system. By that, I mean it's going to allow all the other components to work together and have. This is really where the code is inside the application, if I might put it this way. Then afterwards, another key component is the FME Flow database. You need to know in this architecture, the FME Flow database store mainly all configuration in regards to FME Flow, links, whatever you're going to be setting up through the web interface of FME Flow will be stored in that FME Flow database. So it's really a system database. Then afterwards, you got the FME Flow system share, a little bit like the FME Flow database. Let's say if you're already a user of FME Form, when you're going to be publishing your workspaces to your FME Flow, you're basically publishing to the FME Flow, but those workspaces are going to be stored in that system share. As you will see with the real life scenarios, that system share can be local to a machine or can be on a network drive, for example. And as I was saying, FME Flow, at the end of the day, what you want to do is play with it. So it's going to be over web interface. So the other components is the web application server. And to end all of this with the FME engine, that's really what's going to allow your workspaces to run on the architecture. And there are different FME engine possibilities. So if we start with the different architecture possibilities, we will start with the Express. The Express, as you're seeing, has all the components on the same machine. So you can see the Express architecture as, let's say, you never touched FME Flow before. You're just going to spin yourself up a virtual machine local on your computer, set up and choose FME Flow as an Express install. And in a matter of, let's say, half an hour to an hour, you'll have a machine that is already running, and that is, you are able to publish your workspaces to it, and it's going to be self-running. It's more than that. It's not only like for proof of concept or learning FME Flow. We got a lot of clients that through the course of their journey with FME, they will always stick with the Express installation, but maybe just adding a few more engine because they got more and more workspaces that needs to run. After that, you get to a point where you're going to choose to go distributed. In terms of distribution, you can decide to go with 2-tier or 3-tier architecture. the more often that we see is going to be a two-tier application. We're dividing this into the application tier and the data tier. Basically, in terms of application, you put everything with the web application server, the core, and the engine on one machine, but you will have another machine or other system, might be on the cloud, for example, where your database and your system share will be located. So I took the example of the cloud. Maybe your FME Flow database, you want to leverage SQL Server on Azure to hold the information instead of using the default Postgres database that comes with FME. Same thing for the FME Flow system share. Most likely, if you're under an organization, you'll probably have like network drives already available. So maybe you're going to want to benefit the already existing routine for backups of all your systems. So you're going to put your system share on a network drive and configure FME Flow to access the information to this. Yeah, as you're seeing, you always have the possibility to also have the web application server on a distinct machine. So if I continue in terms of different architecture, fault tolerant, I would say, is the more complex, but as you're seeing at the same time, it's not that much complex. So basically, if you're already in the world of IT, you have other system, it's just FME allows you to use the fault tolerant architecture. So as you're seeing, and you can reflect about the express and the distributed, you would have in this context basically two machines on the right side and on the left side, having all the three components: the web application, the FME engine, and the core. The thing to take into account with the fault tolerant architecture is, let's say you're talking about the FME engines. If you have a need to have two engines for the type of processing that you need to make sure to have two FME engines on both sides. So this way, if ever one side goes down, you're sure you still have the sufficient power to deliver the processing of your workflows. And as you're seeing with all the arrows, it's up to you to decide. Do you want a fault tolerant also on the FME Flow database? Maybe it's going to be something on the cloud again or on-premise that is already by default fault tolerant. Let's say if you're on a cloud provider, maybe the SQL Server is already fault tolerant. The only thing, and same thing for the system share, the only thing to think about as you're seeing at any point in time, you need to make sure that, for example, if the system on the right side goes down, that the other side always have access to both things, being the database and the system share. And if we're pushing a little bit further in terms of fault tolerant, you can also choose to leverage the different kind of engine that Theo was going to talk about and have external optional engines being remote or distributed, or also if you want to choose to, just in case one side goes down, you want to always have other engines available for either GIS processing or other kind of processing. And it's up to you to decide, am I like duplicating this for being fault tolerant, or I just have like one machine dedicated for other kind of processing. And I'll let Theo continue on the engines.
Yeah, that was a good transition. So Jean-Nicolas talked a bit about the different deployment option, but it was also really important for us to put a focus on engine, because this specific component can have a huge impact on your architecture decision at the end of the day. So basically, I don't know if it's an FME engine, but we find it quite funny. We have three main different engine type within FME. So we have the one that we call the standard engine. This is a classic engine, the one that usually, like, I'll say 80% of people will use. It's communicating with the core through network ports. And basically, when you have this engine, you have 24 hours of processing capacities in 24 hours. And on the other end, you have the remote engine. So this one, we like to call it the nomad engine, because instead of communicating through network port, it will communicate through HTTP request and API. So basically, when you are in a situation where you have like data in cloud, data on-prem, and you want your FME core to be in the cloud, but also be able to process the data closer, then you can install everything, all the core component on the cloud, and install a remote engine on-prem and have have the simplicity of communicating through this engine through HTTP requests. So it makes it really more easy to manage. The last one is not really like, I'll not call it a real engine type. It's more of a licensing approach that is quite different. This is the CPU-based engine, also known as the dynamic engine. And this one, basically, instead of paying for one fixed engine, you'll pay for CPU time. So each time you run a workspace, you will have your CPU using some time to process the data, and then you'll pay for that. So it's more scalable because let's say you are in a situation where you need to run 20 different processes, but at the same time, but just for 1 hour in a day, it's better to use CPU-based engine rather than a standard engine. So with those options, now you can understand that you can deploy engine on the same server as the core and on the same network, or on a different network and a different server, or different server, same network. Anyway, at the end of the day, it's really your decision and your use that needs to drive those architecture decisions. So with all of that, there is also other important consideration to take into account. So system compatibility, ArcGIS, licensing, hardware, OS, whether you are on cloud, on-prem, the different type of database that you have, those are really important when you are doing the architecture design exercise. So with all of that, this is what we are seeing sometimes. So a bunch of architecture decisions trying to catch the FME team, and sometimes it's hard. It's hard to decide to take the right decision that fits the organization need. So that's why with our client, we like to make it more simple and to have a two-pillar approach. So think about your business and your technology as the main drivers to decide and to do your architecture decision. So in terms of business, those factors could be like, how many budget do you have? Because if you have a restricted budget, going fault tolerant will be more expensive. What are your use cases? How mission critical are your processes? How much scalability do you want to have? What is your internal expertise? So don't try to go on Kubernetes if you only have a team of 2 IT people that used to work on Windows. That's probably not the best decision. So those factors, those business drivers should impact your architecture decision. And on the other side, technology, then this is where we have more common influencer to drive the architecture decision. So data allocation, security, infrastructure, what do you have in terms of technology stack? Everything should be taken into account to make the right decision. So I know it's kind of theoretical here, so that's why we would like to go deeper and show you 2 different real-life scenarios. So here, this first scenario is from a local municipality of 150K population. They've been doing GIS for quite a long time. The GIS department is mature. They have 5 to 10 FME users, but also at the same time, they have some financial restriction and like they have their own context. So what we like to do with them is to drive them understanding their needs and try to link that after that to the architecture decision. So here, it was an easy one because, and we went into a distributed architecture because first, they needed a database on SQL Server because that's part of their technology stack. They don't want to work with Oracle or Postgres. It's also part of their corporate governance. You need to use SQL Server as the main database for all applications. So given the fact that the built-in database for FME is under Postgres, it was quite an easy choice to go with SQL Server in this case. They also needed to have some scale. They also have some scaling needs for non-spatial use. So they were trying to synchronize like CRM and asset management system, but just for a few minutes each day. But sometimes like the peak of processing time should be able to go up. So having a CPU engine was the way to go for them. But on the other end, they were also doing a lot of GIS stuff, and they decided to install the standard engine, but they distributed this in standard engine on the ArcGIS server, the existing ArcGIS server, because they did not have a lot of budget and they were not able to dedicate an ArcGIS server license just for the FME Flow. Some other consideration, like on the IT side, they needed to go on-prem on Windows because that was the way they manage their infrastructure. Things like SSL, SSO was needed because of some compliance rules, and so on. So at the end, you see, like, it's not a big effort here. It's just a matter of asking yourself the right question and being able to draw the right architecture that fits your needs.
Cool, thanks, Theo. I know I'll go fast on the second real-life scenario. So we're still following. I'll switch to this already so we can take picture. So this scenario is a large gas company. They are already FME widely used across the organization. So the different thing about this one, we already kind of knew that we were going with a fault-tolerant architecture. The way we're using the business and technology pillar is basically to justify it instead of choosing it. As you're seeing, large gas company, large volume of data, Esri Enterprise on-prem, other system on AWS on cloud. They want to use Linux and Windows. So basically, we were looking at, okay, now that we know that we want a fault-tolerant architecture, what is it going to look like? So in this case, they had already some knowledge with Postgres, but they were already leveraging Postgres on AWS. So we didn't change anything, so we used that instead of the built-in. Other things, since they have the Esri Enterprise, as I mentioned, on-prem, then we use what Theo presented before, the usage of remote engine, specifically for having a dedicated machine with our GIS server that license the aspect of the GIS processing. And we still have, if you remember, both sides, standard engine on both machine, 4 engine, like I mentioned, on both machines. So if ever one goes down, the system will continue to work on. So if I continue on this aspect, you're seeing in terms of add-ons to the architecture, we had some machine on Linux on AWS for the core web server and standard engine, because this is the governance rules that they are trying to implement, have Linux first, and if ever needed, have Windows. So for the ever needed Windows, it's the on-site VM with Esri being installed on these. You're seeing we leverage more virtual CPU on the Linux machine because the thing about the daily stuff that needed to run needed more power instead of the GIS. And one thing also to take into account, security is always important. Security was implicated since the beginning. There was already a good connection between IT and GIS. So one example of that is they're leveraging SSL by offloading it in terms of certificate through the load balancer. So with all that being said, you see the importance, either if you're not sure about the architecture or you already have something in your mind in terms of the choice, to go through those pillars and re-question yourself before choosing it. And that gets us to, it's going to allow you to not be like this. Well, I can use one engine, well, then why not use and deploy 5 in 3 different networks, on-prem, Azure, whatever it is, but regret it later.
So that was our conclusion. We tried to make more different. So thank you a lot. It was a real pleasure for Jean-Nicolas and myself to present this topic to you today. Thanks again.
Everyone, thanks for coming out this afternoon. Let's just dive right in it. I'm Mark McCart. I work at SAIC. Been using FME for about 10 years, but enough about me. Let's get into it. That's kind of the game plan for today. Kind of the solution inspiration behind this. This is my little tool that I built over the last 8-9 years. I do a lot of data warehousing where we're pulling data from different sources and then organizing it, maybe changing the schema around, field names and so forth, and then putting that into a geodata warehouse. And what I found was I was trying to document all that field change information on notepads, writing stuff out. I had a lot of non-technical staff in the room, executive leadership that maybe didn't understand how to read XML files or JSON files or SQL interface applications or so forth. And so I kind of landed on Excel. And again, this is just my little tool that I built a while back, and I've shared it with a few coworkers over the years, but this is about it. So I picked Excel just mainly because everyone knows Excel, right? For the most part, everyone knows how to use it. It's pretty easy to format. There's some equations we can use. The one thing that I really liked is if I was transforming several feature classes for a project, I could keep all of that information in a single work file, an Excel file, and use it down the road for documentation. And it's also really nice to be able to reorder attributes if folks need to insert new attributes or maybe rearrange them. And I'll show you that functionality here in a second. So this is the typical setup. It's evolved over time. I mean, what it looks like there may not be what I do tomorrow. I just kind of build these on the fly as needed. So you've got columns, obviously, feature class name and alias, the geometry. And this is where I kind of keep track of an existing field and if we're going to change the name or maybe propose a new field. So if we're going to change the name or the alias, I might highlight it in orange just so it's really eye-catching to folks in the room or on the call. If it's new fields, I just came up with blue and yellow. I went to University of Alaska Fairbanks, blue and gold, go Nanooks. So that's kind of where we landed up on that. And so the new fields are blue and yellow, right? And then if we decide not to use them, I put them in gray, and I usually put them at the bottom. And then again, that comes back into the FME side of things. So that's kind of how it works out. For the example I'm going to show, obviously I changed the look and feel a little bit, but this is it. This is me pulling down a feature service from a DOT. I know I worked in the DOT industry for a bit, so I kind of understand that and where we need to change some stuff up. Some tools that you can use to figure out schema. A brand new one from Esri a couple of versions ago is that Generate Schema Report tool. How many have ever used that? Raise your hands. It's pretty powerful, right? I mean, it gives you everything. If you need domain or subtype information, obviously you have to export out at the GDB level, but for the most part, it gives you pretty good information, but maybe you don't have access to the database table itself. So REST endpoints are good, especially on the JSON. If you need to pull domain information, you can pull that straight from the JSON from the REST endpoint. The schema scanner transformer is great. It will kind of look through your data set, give you a nice summary of attributes, and then maybe an attribute is set to a string of 2,000 characters, but your max is 15. It's kind of wasting database space. I'm kind of a stickler on making sure databases are tuned and set up correctly. Allow for some expansion, but that's a little too much expansion. And so the last piece of the puzzle are these 4 columns at the back end. And so you need a FME field type. So FME has to consume that a little different way, so it structures string and integers a little bit differently. So I've got this handy dandy if statement, concact statement, if buried if statement in there. So depending on whatever proposed field type is entered, string, double, small int, or short integer, however that's spelled, it will just automatically calculate what's needed. And if it's string, it will pick up the proposed field length as well. There are some additional stuff for the new date formats I haven't quite built in here yet. And then FME field alias, in order to pick it up in FME, you actually have to append the underscore alias at the back end. So I just do that again with a simple concact statement, and then give it a geometry. So kind of depending on what the geometry type is, polygon, polyline, I've got an equation that will just pick that up, right? And just give it the right code that FME needs down the stream. And so this is the workspace. It's pretty simple. The top part is, for this example, I was just reading the web service using a feature reader and then a schema scanner to just kind of figure out what attributes I might change or want to change or add to it. But really the heart of it is this bottom part. So a feature reader is just using the schema from table format. It's consuming the Excel. You got to go in there and choose which worksheet you want to use if you have multiple worksheets in there. And then really the key piece of it are these bottom categories here. So you've got to set the feature type, which is your feature class name. The attribute name is the proposed field name. Obviously, the attribute data type is the FME field type. Same with geometry, FME geometry. And then sort order, there was a column in there for sort order. So FME will actually pick it up and make sure your attributes are inserted in the right order that you wanted it to. And that's really, I like this little tool. It comes in handy, especially if I need to reorganize stuff. From a REST endpoint or even database, you like to have your fields kind of organized in a nice manner versus scattered. Oh, I forgot an attribute, so I've got to insert one and it puts it at the bottom and it's not really a good spot for it. So again, the sort order comes in handy, and that's optional. The first 4 are kind of required. Aliases work a little different. So I'm using an attribute creator and I'm importing from Excel. And the key is you got to import attribute value. So you actually have to pull it down. It's not by default. The names are set up there by default. So you got to pull that down. And then the output attribute is the FME field alias, where we appended the underscore alias. And then the value is the proposed field alias. And it comes out something like this on the left and right. And you can hit OK. And then the final piece of it is the writer. For this example, I was writing out to a file geodatabase. I rarely have FME write to SDE directly. I like to do file geodatabase, make sure everything turned out correctly the way I want, and then I'll use an XML document to import it once I get all that. The file geodatabase doesn't need to exist, as many of you know. You just push in a path, it'll create it for you. You can set the coordinate system and so forth, and you want to make sure that this is set to dynamic down there for the table definition. And then once the writer is created, to pick up that proposed feature class name, you actually have to change the feature class or table name down to that FME feature type name. By default, it's just set to FME feature type. So that's kind of a little tricky piece of the puzzle there. And when it's all said and done, there you go. You've got a nice file geodatabase with a feature class in it. And then from there, depending on what you need it for, you can do a little more heavy-duty XML work, set up some domains, subtypes, editor tracking, attribute rules, etc. For most of my stuff that I'm doing for the U.S. Forest Service, we're taking a lot of data from different sources, putting it into our warehouse. So we don't really leverage domains in our warehouse. We're just bringing those values over. But that's kind of the last kind of piece of the puzzle. Again, this was kind of a simple little tool that I've kind of evolved over the last few years, and it's worked for me, and hopefully it might work for you, give you some inspiration. So kind of wrap up is really the tool was built to document schema change, right? So now I've got this Excel file that's got all my notes, where the attributes came from, where they're going to. In the feature class, I got feature class names, and then I can either use that as my permanent documentation or leverage it into other documentation types, right? Because FME can read Excel and then spit it out to wherever you want it. Spreadsheets were useful. I mean, they're simple. Everyone uses them. It's really good if you're you have an audience of non-technical staff, like I mentioned before. And then other than that, just have fun with FME. I mean, this was just something I kind of built on the fly and figured out. And so hopefully this gives you a little bit of inspiration to make your own little tools. And just again, thank you for coming out. If you want to reach out to me on LinkedIn, you can just scan that QR code, and that's it.
Okay, so good afternoon. My name's David Eagle. I work for Avinion Tenzing. You can probably get a clue as to the content of the session, Pixel Puzzler. I'm a technical user of FME since about the year 2000. I part of the SAFE value-added reseller network, working with SAFE software to both sell and work with our customers around the FME technology stack. Certainly Bill Gates was at least cited as saying that 640 kilobytes of RAM should be good enough for everyone, right? But, you know, the 2 gigabytes, the 8 gigabytes of RAM that we have sitting in our pockets kind of indicates that perhaps that wasn't quite true. Dale Lutz kind of rused the day that he ever said that FME would never do raster, because in 2007, you can see this is the very well-known trajectory of data formats in FME. There's raster coming in, so raster getting the vector treatment. If you want to scan that QR code, you can go to the rather nostalgic historic document that tells you all of the different bitmaps and PNGs and JPEGs that all flooded into FME and gave people raster capabilities in our favorite ETL software stack. So what you perhaps expect me to talk about now is clipping and zipping and shipping and working with tiling and mosaicing and the kind of bread and butter of FME, and everyone's heard that all before. So we're going to look at photographs and images and squirrels and cars and sheep and livestock and office spaces. If you haven't come across or been introduced to the concept of dark data before, dark data is the huge volume of information that we're recording with our systems, with our IoT devices, with our sensors and our call logs and site survey photos that we never get to look at and we never extract any value from. And that is a huge untapped potential. The data, not only does it cost us a huge amount to store that information, but we can't look away from the climate crisis and the fact that storing information we're getting no value from is an environmental impact as well. There may be legal or compliance issues with us storing information about our customers or our personal information tucked away in that data that when we want to be removed from an organization, we can't necessarily be sure we're having all of that information removed. It's awkward to search, it's difficult, it's frustrating. I mean, if you think about dark data, just look on your own camera roll. How many photographs do you have of the food you ate last night or in this wonderful venue today that you'll perhaps never look at, but you're probably going to leave on your device for at least a few weeks until you get around to removing it. When you look at that in more of a survey or analytical concept, here's a series of images that relate to site survey, roof condition survey information, potentially hundreds or thousands of images of roofs that maybe have something that a site maintenance person needs to deal with, a cracked tile that might mean and lead to the ingress of water into a building, moisture and damage to that property. Really, are they going to look at hundreds or thousands of photographs in detail? Well, wouldn't it be nice if the machine could help us point our attention more towards the photographs that need to be reviewed by a human? We've now got our own capabilities in our pockets to replace the face of the individual that we've just taken a photograph, hopefully with a smile rather than somebody else's head. But you can also see that devices give us the ability to categorize raster imagery, categorize our people and pets, our friends, our family. Computer vision technology from the early 70s now manifests itself in the ability for us to sit in a restaurant and work out what we're about to eat in a foreign language, or what road sign is going to warn us about in the distance in real time by just pointing our device at it. The thing is, we have eyes that are attached to brains. The two work hand in hand to have depth perception and have an understanding and an assimilation of what we're looking at. But computer vision needs to be assisted. It needs to be helped. And whether you know it or not, you've probably done that. You've probably tried to log into a site, fill in a reCAPTCHA or CAPTCHA form. reCAPTCHA was one of the early ways in which a large amount of hard copy documentation was turned digital by the likes of Google. Now you've got challenges of trying to prove that you're not a robot by working out the intricacies of images, but you are helping train models like Gemini that are going to be able to help you in your orchestration processes find and spot things like traffic lights or street signs or bicycles or whatever the flavor of the current week is when it comes to capture. If you want to know the story behind this, I'm not going to have time to tell you why I'm showing you raccoons, but if you want to find out, I'll happily tell you afterwards. But I want to show you a little workflow that looks at some of the technology that we've got natively in FME to help us go and do some analysis on photography, imagery. This is a relatively old tool now, AWS recognition. The transformer was introduced into FME in 2017. It gives us the ability to look at face detection, image moderation, object detection. Personal protective equipment is the PPE acronym. So looking at, say, CCTV footage of a construction site and work out if our personnel are wearing the right PPE when they're on site. And what we're doing here is we're going to read the image of the kitten and the raccoon, pass them through the recognition connector, and then take out of that, parse out the response, and see if we can identify what we're looking at here. There was a time when notoriously cats and raccoons or cats and bears were indistinguishable from one another from a computer vision perspective. And you'll see here that if we take a look at the results, we can see we've got a cat on the left there, and we've got a dog on the right. So first of all, we have a cat and a dog. So if we take that on a little bit further, systems like Similar, this is a service that's been around for a little while, a little bit younger, and you can see here that the focus is often in retail with Similar. It's good for product identification, and you can see that we have to extract the photograph and binary encode it, and then we can push that up in our post request. We're going to send that up to the Similar API, and you can see that the body of the post request includes the base 64 encoded image that we can pass to that service. And we need to do a little bit of work with the JSON response to parse it, but we're going to get a series of keywords back. And we can see that this time round we've got an animal, we've got a cat, we've got a feline, a kitten, we've got two of them, we've got two cats. So we had a cat and a dog, and now we've got two cats. We still don't have our raccoon. So if you move on to more modern times and start to look at tools like OpenAI and Gemini, that's where it gets really exciting. And you can see that we can go, in this case, using OpenAI. It's all about the prompt. I'll touch on the prompt in a moment. Many of the previous sessions in this track have described the importance of how you provide the prompt. But here you can see we finally have a domestic cat and a raccoon. And you can make it give you back the traditional name. You can go for the scientific name. You can have a look for things that it knows about raccoons that aren't in the photograph, or things that are exclusively in the photograph. Why? I mean, partly just to give you an example of some of the fun things you can do with FME, but if we start putting some interesting asset-related imagery through here. So it was mentioned in the plenary, but we work with an organization called Workspace Group, who are focusing on office lets and office provision of access space in London. And you can see here that if you use something like AWS recognition, you can start to look for things that are in the photograph and identify where they are and generate a keyword that references the thing that we're looking for. But where this starts to get interesting is when you use tools that can give you keywords. We worked with Workspace. The primary brief was to take data from SharePoint and load it into their digital asset management system. And what we discovered through talking to them a little bit more was that when somebody rang up and asked them for an office space in Islington in London, their next thing was to say, well, I'd like it to have exclusively wooden floors and lots of natural light. So if we can send the image to a keyword generation tool and populate metadata about each individual image as part of that orchestration to load the image into the document management system and tag that, it's really handy. Where it gets perhaps uncanny or scary is when real estate and estate agent personnel start to see the kind of response that you can get back to describe the space in a particular set of context here. Tell me about the materials that are used in the image, the ambience that you're experiencing, and you can see in that photograph, you can get some really rich content back. So if we just step through, just to look at prompt engineering for a moment, only a couple of weeks ago, Google released I think 69 pages worth of prompt engineering advice. If you go and search for white paper prompt engineering, Google or Kaggle is the host site, you can see some really interesting focus on how to ask AI the right question. And you can see the types of questions that we were asking to get some of the responses we were looking at in this example. If you go to SAFE's website, again, you've got access to the full case study that you can take a look at to find out a little bit more of the detail for the Workspace Group case study. Some of the tools that we're using in the examples that you saw my colleague Oliver talking about yesterday in the afternoon session are in our hub verified publisher account. So to access tools like Google Gemini and Olama for local AI, if you're more concerned about security and having the AI locally on the model locally on your machine. Another technology stack that I'd like to introduce you to that's really interesting, we were doing some initial R&D around a toolkit called RoboFlow. The thing that's interesting about RoboFlow is it introduces the concept of pre-trained, openly accessible models. So there are hundreds and thousands of models that are pre-trained on particular topics. People have uploaded and shared their photographs and have done labeling and tagging of the content within them on each theme. And they're available at the RoboFlow universe, where you can browse some of the pre-trained models that are available there. Once you have created your model, they have an API endpoint, and then you can easily use our favorite orchestration engine to be able to request information back. So this scenario is just going to show us a quick workflow that takes an image of our car park, our vehicles parked up. Certainly when you're driving around the UK, we're often getting zapped by something called an ANPR unit, an automated number plate recognition system, which generally gives us a ticket for infringements of one description or another. Effectively, we built an ANPR tool directly here with FME. We're going to read in the image and we're going to binary encode it. And again, we're going to issue that to RoboFlow. And what we're going to do here is we want to hunt for the location in the image that has the number plate, the thing we care about, and ignore everything else. So here you can see, and I'm going to jump this on in a second, but you can see that we're going to pass the raster image and send it off, parse the response back from RoboFlow, and you can see over here that we're building the geometry that shows us the location. Let me dive back. I have a movie that's gone out of sync. There we go. There we go. So we make the request to the API endpoint, and you can see that we've got the service that we're using in RoboFlow. There are 10,125 photographs that the wide RoboFlow community has published and then has tagged. There's the endpoint. You can see that we just have to pass in our own key, the base 64 image, and parse the response that comes back from that service. So let's just dive on a little bit. The geometry placer, once we've got the X and Y coordinates of the number plate, allows us, there we go, there's the bit I wanted, which shows us the size, the height, the width of the box, and it gives us a percentage confidence. So we've got an 80% confidence that we've probably found a number plate at that location. Then we can construct that with our little attribute manager here, generate the coordinates of each corner of the box, replace the geometry so that we now have a box that shows us the location. Then we've got a clipper just below it that we can cookie cut that content out with. So there we go. We can see the location that is highlighted where we are. The point is that once we have clipped that content, we can then go and send that to Gemini. And the Gemini section is just up here. We can issue it to Gemini to do effectively a character recognition, a text read. Because what we want to do is extract the content. You can see there we've got our number plate that is coming back in the structure that we asked it to be returned in. And then we can go to the driver and vehicle licensing agency in the UK and check to see if that vehicle is correctly registered and what type of vehicle it is, whether it has the right papers to allow it to be on the road. That's kind of a very traditional workflow that we can see. And the reason why I'm showing you some squirrels is because I showed that presentation to a group of individuals at one of the UK tours that we do. I could see one of the guys in the audience visibly sort of shaking. And at the end, he just said, "Squirrels." And I said, okay. He turns out he's involved with a local wildlife trust. He has hundreds of hours of trail cam imagery. He's involved in the Wildlife Trust, trying to repopulate an area of the UK with the native red squirrel that has been besieged by the incoming grey. And he wanted to be able to spot the locations in these movie files. So we introduced him to a knowledge article from Dimitri Barg, who had a really great article on the Knowledge Center, focusing on orchestrating FFmpeg, which is an open source movie extraction tool, chopping up the movie into individual photographs, which we could then pass to a trained model. We showed him how to train RoboFlow. He did it in a few hours, and now he's got an orchestration tool that allows him to look at the particular parts of the movie that finds the animals that he's interested in. We took exactly that scenario to UK Power Networks when we were looking at identifying cross-sections in their historic plans. This is the key item that we were looking for, including the ID number that's associated with it, because that's the location of a cross-section plan that we have associated, which is the cross-section image that you can see on the right-hand side there. Using exactly the same technique, RoboFlow is extremely good at finding the arrow itself through a way of training the model. Gemini, however, was much more accurate at finding the number, the ID number. So we joined the two forces, and that's one of the messages we want to get across, is you don't have to stick to one AI tool. You can daisy chain them together to get the best of the tool that you desire. In this case, to train the model took about a day with kind of 400 or 500 images. The beauty of the RoboFlow platform is as you train it, it starts to become sentient, because it starts to identify the things that you are interested in real time, and you can say whether it's correct or not, and it labels the pictures much more quickly because it learns. So in a very short space of time, we were getting, well, it's a couple of days elapsed time here of training and computing the model to get a 75–80% level of accuracy for change, small change really, in terms of an AI service. Now, if you're interested in kind of these scenarios, I would recommend you go and have a look at some of the historic webinars that my colleagues Oliver and Simon and Siobhan have been involved in for looking at Amazon Bedrock and AI agents, and also the capabilities of Google Gemini. safe.com/webinars, and have a look at the published webinars that are there. I'd also encourage you to, wherever you are on the AI spectrum, whether you're a skeptic or an early adopter or a futurist, this BBC podcast is a really interesting one. There's a podcast session in there for most of you that I certainly enjoyed and found really interesting on the topic. And just to finish off, because I'm at time, a little bit of fun for all of you, and certainly this is something that I can pick up with you about what's going on behind the scenes afterwards. But if you have a device in your hand and you'd like to scan that QR code, there is a little app at the end. And what you can do is, this is going up to a public service, so I would recommend that you take a photo of something that belongs to you and not somebody's face or your face from a privacy point of view, but take a photo of your foot, your laptop cover, a nearby chair, a shoe, your hand. You can see that in order to do that, you will have, partway down the app, there's a button that says Browse File System. If you push that, it will activate the camera on your device, and then you can take the photograph and tick the box on the right-hand side, hit Run, and that will submit the photograph to our little FME Flow app. It's going to analyze the picture, and it's going to classify your data type. And your data type is going to be picked from a set of categories that we gave the service, and it's going to have a look at the photograph, and it's going to give you back a little amusing comment about your data type and what it sees in the image. And it's just a scenario. We only have one engine sitting in the back end to process it, so that information is just going to come back to you. Be a little bit patient, because it's not a production ready solution with a million engines ready to parse the response, but you should get a streamed response back that looks a little bit like this. You will be classified as a data type with a fun little reply there. But it's just a little bit of a tidbit just to show you that you can turn these tools into an app. You can use some of the AI services as part of your general orchestration. But there we go. Thank you very much. I'll just leave that there.